Hello students, welcome to the classroom point. In today's session, we shall discuss the multiple choice questions based on the unsaturated compounds, means alkenes and alkynes. So in this today's session, we shall take some of the questions. The first question is, there is one cyclohexene molecule is given. It is giving the methyl cyclohexyl ether. So how to obtain this particular compound and what are the possible options helpful in obtaining this particular methoxycyclohexane from cyclohexene. So let us take the question number 1 now here. So if you see this question mechanism, we need to see the mechanism of each and every question here. Among all these options, there is H plus ion. So H plus ion initially attacks over the alkene part and producing. So here the attack will take place like this, and one of the carbon that loses electrons gets the positive charge. So this particular positive charge, the cyclohexyl positive charge 1. Here if you see, methoxy part is there. So methoxy part is with the option A and not other options. So if you take the methyl alcohol, in methyl alcohol, oxygen generally carries a pair of lone pair of electrons, which acts as a nucleophile, so that it preferably attacks over this positive charge and produces an intermediate unstable compound like this, which on loss of H plus ion, because oxygen with a positive charge is unstable and it withdraws the electrons from the oxygen hydrogen bond, so that H plus ion will be released finally, and here we get the molecule like this. Hence option A is correct. And here the important thing to be noticed here is, whatever the hydrogen we added here is from the acid that we are adding, and whatever the H plus ion is released in the final step is from the methyl alcohol. So if you use the deuterium here, you will get the deuterium over here, and if you use the deuterium here, and you will get the deuterium out of the molecule in this particular step. So option A is correct for this first question. Now let us see the second question. So in the second question, CH3 CH double bond CH CH, that means butadiene, is giving this particular molecule. It is a simple question, just like in the first question. So extra thing to be observed here is CH3 CH2O, that means ethoxy part is there. So ethoxy part is present among all these option is C. So let us try to get it the molecule done. How to get this particular molecule? So if you take this molecule and subject it to the H plus ion, again in all these options H plus ion is there except here, which is HOCl is there. So H plus ion approaches the alkene molecule. Due to the electromeric effect, there is a electrons that shifted over to the hydrogen and gives one of this particular carbon as a positive charged carbon. You may create the positive charged carbon. Moreover, this is a symmetrical alkene, so that you can put the H plus ion either this carbon atom or this carbon atom. There will be no difference in the final formation of carbocation. So this one on reaction with the CH3, CH2, oxygen and hydrogen, again ethyl alcohol, which is a good nucleophile, so that attacks like this and produce CH3, CHO, CH2, CH3 and hydrogen here, and this side also CH2, CH3, positive charge is there, and the final step again loss of H plus ion from this alcohol part and giving the CH3, CHO, CH2, CH3, and here also CH2, CH3. Hence option C is correct. Now let us see the question number 3. The question number 3 is again similar molecule, but the part is different now. Here HOCl is there, so you just search for the reagent that is having the HOCl. The simple thing that option D is having. Anyhow, let us see the mechanism here. Cyclohexene subjected with the H plus ion as per the concept what we think here is, but actually H plus ion will not attack, so that you just see it is HOCl molecule which dissociates into the OH minus plus Cl plus ion. So that this Cl plus ion preferably attacks over this particular alkene molecule, and you may observe the thing between these two, why the Cl plus ion is preferably attacking and not the H plus ion. It is simple thing that Cl plus ion is first of all unstable. Though H plus ion is unstable, but Cl plus ion is more unstable because it is actually, if Cl minus E means it will be stable due to the noble gas electronic configuration. So by the loss of the electron, it becomes more unstable. Moreover, it is more electronegative than the H plus ion. So that it preferably try to attack over the alkene molecule. And the second thing is the carbon Cl bond is too strong. So here we get the Cl at one place, at another place positive charge one, and next step OH minus ion attacks over this positive charge and giving our required molecule like this. Hence option D is correct. Now let us see the question number 4. So in this question number 4, they had given the one alkene molecule finally been converted to the alkane molecule. So these are all reducing agents. Among these all reducing agents, which is most preferably be attacked and will be used. And simple thing is lithium aluminum hydride, sodium borohydride, though they are the strongest reducing agents, they are unable to convert the C double bond C to the C single bond C. And hydrogen, palladium, calcium carbonate, this is the Lindlar's catalyst if you use the acetic acid. Then this Lindlar's catalyst do not convert the alkene to the alkane, it converts only alkyne to the alkene. So H2, nickel or platinum or palladium is the preferable reagent that used to be used in this particular reaction. So option B is correct. Now let's see the question number 5. So in this question number 5, though a little bit big, okay, anyway it is visible to you all. So one molecule is given, alkene molecule, dilute H2SO4 and water is also given. So among these compounds, which is the compound that is possible, they are asking. So I'll write the molecule and its reaction. I do not touch this one, so that based on the final product we can select the option here. I'll write once again 5 here. So pH, CH2, CH double bond, CH2, dilute H2SO4 in the presence of water. Even water is not necessarily to be used. Once dilute H2SO4 is used, automatically you have to think that water is present in that H2SO4. So it gives H plus plus HSO4 minus ions. As usual, H plus ion will attack on the double bonded carbon atom, and this is the non-symmetrical alkene. So according to the Markovnikov's rule, positive part of the reagent will be added to the carbon with more number of hydrogens. So pH, CH2, CH single bond, CH3, and here positive charge. This is secondary carbocation, which is stable to some extent. But in this particular process, this phenyl group is connected to this particular carbon, and this particular carbon is a benzyl carbon. So that is the reason why what happens here is one of this hydrogen will be shifted over to this carbon. So here 1 to H minus shift, that means hydride shift takes place, and we get pH, CH plus, CH2, CH3 will get. This is also secondary carbocation like this, but this is secondary benzyl carbocation. So secondary benzyl carbocation is more stable than the normal secondary carbocation. So now what happens is OH minus attacks. Actually HSO4 minus attacks over here. Okay, I'll write that reaction first and later OH minus and we'll consider it. So you just take the HSO4 minus and giving the pH, CH, HSO4, CH2, CH3. Hydrogen do not react, actually do not connect. It is SO4H you can write, and this on reaction with the water. So water disconnects this bond, adds hydrogen this side and OH that side. So we get the molecule like this. So let us try to search for the option given among these. Is here OH is present, CH, so option A is correct. Let us solve the question number 6 now. So in this particular molecule, this is the reactant molecule given here, and to which dilute H2SO4 is added. So you just consider that H2SO4 dissociates into H plus HSO4 minus. So H plus ion will attack either this carbon atom or this double bonded carbon atom. But according to the Marconi-Clausius rule, H plus ion has to attack over the carbon with less number of substituents or more number of the hydrogens. Then H plus ion preferably attacks over, and these 5 electrons will be shifted over to this carbon atom, and here we get the positive charge. So this is the tertiary carbocation which is more stable. So this tertiary carbocation, next again HSO4 minus, even not necessary to write down this reaction every time. It is understood that HSO4, because HSO4 immediately reacts with the water and giving the its respective alcohol part. So OH will be added over here, hence option A is correct. Now let us see some other questions. Question number 7 here. So in this question number 7, cyclohexene part is having the nitro group. So this is one of the important compound. It generally do not follow the Marconi-Clausius rule. The reason here is NO2 part is connected to the one of the double bonded carbon atom. So whenever the electron withdrawing groups like NO2, CNR, these are connected to the one of the double bonded carbon atom, then if the positive charge is created at that particular carbon atom where this electron withdrawing group is connected, that carbocation becomes unstable, because electron withdrawing groups makes the carbocations unstable. So that is the reason why H plus ion preferably attacks over this carbon atom, not this carbon. So I will write in the two possibilities here first of all. If H plus ion attacks over this carbon atom, I will take it as a one blue color compound, blue color ink I use it. So NO2. So if H plus ion attacks over here, here you will get the positive charge. Now let us take the green color. Imagine that H plus ion is attacked over there. So here NO2 as usual. If H plus ion attacks over here, you will get the positive charge over this carbon atom. So this particular carbocation is more stable. Why? Because NO2 part, which is electron withdrawing group, is away from this positive charged one, and here NO2 part is connected to the positive charged carbon, where it makes the cation more unstable. So that is the reason why this preferable attack will take place. So I will write down that particular reaction. So here NO2 and here positive charge, and immediately dilute H2SO4 means that HSO4 minus step I am not writing, you just take the water directly. Water means oxygen to lone pair of electrons, here positive charge, it attacks over here and giving NO2 and there is a loss of H plus ion like this. And finally we get this molecule, hence option C is correct. Let's solve the question number 8. So this is non-Bornene molecule, shape is like that non-Bornene, methyl group is present, and this molecule is unstable. Again, now let us take the dilute H2SO4. Why I said this is unstable way? Because this particular hydrogens, bridge hydrogens, do not participate in the hyperconjugation, so that makes this alkene molecule more unstable. So H plus ion attacks over this particular carbon atom, because this is an again unsymmetrical alkene. So according to the Marconi-Clausius rule, it attacks over the carbon with more number of hydrogens, so that it attacks over here and here, giving the positive charge, and here we get the CH3. this one on reaction directly I am taking the H2O, and this is first step, and the second step is loss of H plus N. This particular step was discussed in the 7th question. The same step will be there. You just see that question. This is the molecule. So hence option A is correct. Now let us see the question number 9. So in this question number 9, let's take this molecule and subject with the dilute H2SO4. These are all dilute H2SO4 combinations which gives H plus N. So H plus N can attack either this carbon atom or this carbon atom. Whatever the carbon atom, it may be final product will be the same. I'll explain you the reason why. So if H plus N attacks over here, positive charge will be created here. So here we shall take the molecule like this, CH plus, CH2, CH3. And if H plus N attack over here, then the molecule becomes like this. So positive charge will be created here. Why? Because these 5 electrons will be shifted over to this carbon atom. CH2, CH plus, CH3. So it must be understood that whenever a reaction is proceeding via the formation of the carbocation, then we must see that it will participate in the rearrangement till it obtains the stable carbocation. So it is a secondary carbocation, so that one of these hydrogen shifts over to this carbon and giving the stable tertiary carbocation. CH2, CH2, CH3. So this one is the positive charge. And here what happens, this is secondary carbocation like this, but this hydrogen will shift over here. So after shifting this hydrogen here, it will make this secondary carbocation, and again this hydrogen like this again will be shifted, means it again participates in the 2 times hydride shift. This is 1,2 H minus shift, hydride shift. Here also 1,2 H minus shift, hydride shift takes place, so that we get the CH plus, CH2, CH3. Again after 1,2 hydride shift, again we will get the same molecule. So this particular molecule, since we said the dilute H2SO4, so it has to be subjected with the water molecule now. So water is having the pair of electrons, so that it attacks over this particular positive charged carbon and giving CH2, CH2, CH3. Here hydronium ion part and loss of H plus ion. Final molecule becomes like this. So option, let us see among these options, question number 9. So among these options, option D is correct according to the answer. This is the answer. So it must be visible to you. So if you are feeling that if any step you are missing, just you pause the video and see that once again. So let me explain the question number 10. So according to this question, CH3, CH3, just I am writing the reactant molecule which will facilitate for me to explain the mechanism. So that again this is unsymmetrical alkene and positive charged ion is approaching this unsymmetrical alkene, so that preferably it attacks over the more carbon with more number of hydrogens, double bonded carbon with more number of hydrogens. So CH plus and CH3. Now the thing is, here this is secondary carbocation which is bit stable, but if this hydrogen is shifted over here, that means 1,2 H minus shift, then it will be able to provide the tertiary carbocation. So any reaction that involves formation of the carbocation as the intermediate, that reaction no doubt participate in the hydride shifts, methyl shifts, phenyl shifts, methoxy shifts, anisole shifts, till it is able to provide the more stable carbocation. So this is the tertiary carbocation which is still more stable. Again we are using the dilute H2SO4. Directly I am taking the H2O. This is the first step, and the second step is 1 minute, I will write down this loss of H plus ion. So loss of H plus ion. So directly we get the CH3 OH, CH3, CH2, CH3. So this is the answer. Luckily it is here only. So dear students, if you like my explanation, do not forget to share these videos to your friends and comment whatever you feel about these videos, and like this video, and finally do not forget to subscribe this video, and please do support me. Thank you.